Hola, mi nombre es Tomás Hunter y no hablo español. So now that I've used my complete Spanish vocabulary, I'm going to continue in English. So welcome to my talk. This talk is, of course, the long road to async and await in JavaScript. If you feel like giving me some free internet karma, please follow me at tlhunter. And earlier this year, I published a book called Advanced Microservices. And so if you use Node to build microservices, or if you're interested in system-oriented architecture, feel free to check it out. So throughout this talk, we're going to look at the evolution of asynchronous control flow as it exists in JavaScript. And so much of this talk will apply to both browsers and Node. And so I kind of break it down into a few different phases. And so the first phase is callbacks. The second phase is promises. After that, we have generators and their yield keyword. And finally, we have what everybody's looking forward to, I hope, async functions and their await keyword. And so each one of these phases will attempt to build upon the ones that came before it. They'll attempt to introduce perhaps new syntax or other niceties which make the language easier to work with. But before we get into that, we're actually going to look at phase 0, which is synchronous code. And so here's an example of synchronous code. So all this code will execute in a single stack. Earlier we mentioned that JavaScript is a single-threaded language. And so what that means is that we're not actually able to run multiple lines of JavaScript at the same time. And so we need to be able to break up the work. And so the synchronous code runs from start to finish, but we're not able to actually perform other work in between. So this code also looks pretty nice. Notice how within our function, the code is pretty flush on the left. There's minimal amounts of boilerplate required to get this code to run. So the first thing what we're going to do is execute the send message function. We're going to pass in 2 arguments, user ID and a message. And then so the first thing we're going to do is get some information about the user. We execute this getUser function, passing in the user ID. And so since this is synchronous, perhaps it's reading information from disk using the synchronous operations in Node, or perhaps we're just getting data from a giant object somewhere. Once we get that data, we can then pass it into the canSend function. That'll let us know if the user is able to send this message. We will then check to see if the user was able to send the message. If they're not, we're going to return a false, and our whole function is just going to resolve, or it's going to end up returning a false value. Otherwise, we will call this writeMessage function, which will actually deliver the message, and then we return the result of that to our caller. And so here's what error handling looks like with that code. So we wrap our call in a try-catch. And so within this send message function, if we throw an error, that error will be caught in the location where we called it. And so when we run this code, our catch will call. We will log the error to the console. We will not log the result of the operation to the screen. So yeah, this code is pretty nice. It's pretty ideal. It's short and to the point. But there's, again, that shortcoming I mentioned earlier, in that once we're running the code in this function, we can't stop and perform work elsewhere. That's, of course, where callbacks come in. So quick show of hands, who uses callbacks? Come on, every single one of you. We all use callbacks. So, of course, callbacks is the philosophy used by Node. All the APIs under the hood is any of these APIs which perform any form of I/O. They accept some sort of callback parameter, unless you're using their synchronous blocking functions, which you definitely shouldn't be using. So the code for callbacks looks a bit like this. You're probably wondering what those alarm clocks are doing in there. And so while it is true that we can use emoji in our identifiers in JavaScript, don't actually think of these as being identifiers. Instead, they're sort of indicators in our code. At what point in time are we actually performing asynchronous work? At what point in time do we sort of exit and then come back and run code later? So in this case, we have our beloved send message function, which accepts the user ID and message parameters. But this time we're accepting a third parameter, which is, of course, our callback. And in Node, the pattern is that the first argument of the callback is an error, and then the following arguments, if applicable, has the result of the operation. So as we execute the send message function, we accept that callback. We then call out to this getUser function. That function also is a callback style function. So we pass in the user ID. Perhaps it's going to our database. It's getting some information about the user. Then it returns the information. Once that information is returned to us, we're able to continue running our application. So since the time where we started making that getUser request, and since the time that we get the result, our application was able to do other things. So for example, it could be answering, we're getting requests. Perhaps we're a web server. Express is handling other users' requests. And then once this callback is firing, we're then able to continue where we left off. And so again, we have the send method, the can send method, which needs to fire next, and that accepts the user object in another callback. And again, we're able to do other work. We come back, we run our callback, and then finally, we check to see if the user was able to send a message. If they're not able to send the message, we execute the callback, and of course, we pass in, there's no error, so we'll pass a null, and then the second parameter will be the result we want, and then we return. So one interesting thing about these callback functions is that we never actually care about the value within the callback, which is returned. We only ever care about executing that callback and passing in the parameters into it. So if you think about just functions in general in JavaScript, there's really two ways to interact with them. One is to pass data into them using an argument, and the other is to return data from them. And so as we use the callback pattern, in a sense, we're only using half the features available to us in these functions. And so finally, we call the write message, where we pass in the data it needs in a callback, and then the write message function will handle passing the data that we need into the callback. And so, of course, if we have errors, we don't actually throw errors using callbacks. If you do, bad things will happen. We're not really able to catch them. So in this case, if we do have an error, what we want to do is execute our callback, where the first argument is a truthy value. You should be using a new error when you do that, so that the calling environment is able to get stack trace information. Also notice that I've wrapped it in a set immediate call. You don't want to actually call a callback in the same stack from which the function was executed. Instead, you want to call that function in the future. If you don't do that, some strange things can happen, which may confuse people who use your API. But normally, the callback is going to fire with an error, sometime in the future anyway. And so once our original callback fires and we get that data, we then check to see if the error is a truthy value. If so, we do something with that error. Otherwise, we use the result and we continue our application. Cool. And then, so one kind of gotcha with this pattern is that we always have to have these checks for errors. And so as you see, I've added these two error checks inside of getUser and canSend. And so what these do is they check to see if the error exists. If so, they fail the operation, they call the callback and they return. Otherwise, we're able to continue. And so also notice the pattern of this code, whereas previously when we were looking at synchronous code, we get a nice flat line. However, with this callback code, we're starting to get callback hell. We're starting to get this giant V. And so phase 2, we have something called promises. And so this was introduced in ES 2015. Of course, promises didn't introduce a new syntax, so we're able to polyfill it. And so anybody here use Bluebird? Cool, a few of us. Yep, so Bluebird is probably the most popular promise polyfill. So promise code looks a bit like this. With promises, we do actually return something from the function. So in this case, when we call our send message function, that send message function is itself a promise. It's a promise function because it returns a promise to us. So in this case, we're able to pass in just the two arguments this time. We don't have to pass in a third callback argument. And then we're able to do some method chaining, essentially. And so we call the then method of the promise, which is returned, where we register a callback with that promise. When we actually execute our send message function, we take the arguments, we call out to another function, in this case getUser. This time getUser is also promise, and so we pass in the user ID. It returns a promise to us, which we then register this callback. And then the result of that promise, we actually call another .then, where we pass in another callback, and we say, hey, run this code, once that callback is complete. And so what ends up happening is our getUser function ends up firing We get the result from the database. It'll call our callback function. Inside that callback, we execute the can_send method, passing in the user, which we got from the promise, and then that returns a promise. Once that resolves, we call the next.then, which calls our callback. If the user's not able to send a message, we return a false. And so if we return a value from a promise, it is available to the next step in the chain. So in this case, the overall promise would resolve to a false. Otherwise, we're able to continue, so we return a call to write message, which is itself another promise, as you could probably guess. And then so we get the value from that, and then the overall promise resolves with the result of that operation, and we log the message to the screen. And then so if we want to handle errors in promises, we don't really call them errors, we call it like a rejection, and so we reject the promise. So in this case, we call the send message function, we pass in the user ID, the name. Inside the send message function, we return a promise which rejects, and we reject it with an error. And then so what that will end up doing is instead of calling our then, it'll call our catch, and then we're able to use that error. So promises are pretty neat in that they actually use both the arguments passed into the function, and they're able to return something from them. But at least for me personally, I'm not a big fan of the syntax. Our code with promises ends up kind of looking like a zigzag. Really, I'm looking for that flat line. So with phase 3, we get something called generators. And so generators became available in ES 2015. And so generators represents a new syntax, which means we can transpile it using something like Babel, but we're unable to use a polyfill. And so generators were first introduced in Node version 1.0, which many of you may remember as being called IOJS. So the syntax for that looks a bit like this, looks a bit crazy, but we'll get to a less crazy version pretty soon here. And so that our send message function is now a generator, which you can see because we have that asterisk between the word function and the name of the function. And then so these generators, they're able to yield information from them. So let's go to the top of the screen. So the first thing we do is we take the send message function, we pass arguments into it, and then we assign the result of that to this variable called gen. And so that is now our generator. And now what we're able to do is we're able to call gen.next, and what that does is it starts to run the generator. And then so we go into the send message function. The first thing that really happens is that we call the get user method, passing in the user ID. And then get user in this case is also a promise. And then so that function returns a promise, which we then yield. And then so that yielded promise becomes available to us after the next call. So when we call our .then, that now represents the first promise from get user. And then so once that promise resolves, we execute this callback here. And so that callback gives us the user value, which we can then call back into our generator. And so we call gen.next again, passing in user. And so we take that data, we pass it back into the function, and then so that yield, the result of that yield, which is the user, is now assigned to the user variable. And then we're able to move on to the next line where we take the user, we pass it in a can_send, and then the process goes back and forth. And so one thing that's kind of interesting about this pattern is that the generator is yielding data to us. This information is coming out of the generator, it's coming back into the calling environment, and then we do something with it. In this case, we wait for the promise to resolve, and then we pass the data back in. So it's a sort of interesting, back and forth process, which in this case, where I've done the code manually, looks pretty scary. But a good thing about this code is that we are much closer to our ideal situation, where at least the send message function code is nice and vertically aligned. So luckily for us, there's this cool library called Co. And so what Co will do is it will actually wrap a generator, and it will return a promise. And then Co will actually go through, and each time that we yield a promise from the generator, it will then wait for that promise to fulfill, and then it will pass the result back into the generator. And so this makes our code a lot easier to work with, because we don't have to do all that crazy manual effort of passing the data back in and taking the data back out. Unfortunately, with this approach, we do introduce at least one more indented level, because we need a new function that wraps our generator. So the code is pretty nice, but it is not quite perfect. And then, of course, if we want to handle a rejection, what we can do is yield a rejected promise from within our generator. And then what it will do is it'll call the catch, where we call the code. And so these generators, they're actually sort of originally intended to be used for, perhaps generating things over and over again. So one of the use cases with generators is that you could have a function which would yield, an ever-incrementing integer from 0 to infinity. Well, not infinity, but, really, really high number. And so we're able to sort of repurpose generators. And so by returning these promises, we're able to use it for asynchronous control flow in this fashion. Finally, we have phase 4. And so this is part of ES 2017. Again, it introduces a new syntax, and so we're unable to transpile, we can transpile the code, but we cannot polyfill it. And of course, it became available in Node.js version 8.3, and as was mentioned earlier today, in 3 days, Node 8 will become LTS. So I expect every single one of you to put in a ticket, at your company to upgrade to the latest version of Node next week. Also another interesting fact is that Microsoft Edge was actually the first browser to implement async and await. I was looking through the docs earlier, and the people who championed this feature in TC39 appeared to be 2 Microsoft employees, which makes sense. The async and await feature was highly influenced from the C# language. So here's our async and await code. Let's see, so if we have a function which is an async function, what we do is we precede the function call with the word async. And so at the top we have an anonymous fat arrow function, which is an async function. It's also an immediately invoked function execution. And the reason we have to do that is because, for example, if you're writing this code in a REPL, or if you've loaded this code in the top level of a file, that top level function is itself not an async function. And so, for the sake of these slides, I need to wrap it in that IFI. And so inside of our send message function, when we execute this code, much like the generator syntax, we're able to run these functions and then await on the result of that. So in this case, what we do is we execute our IIFE, immediately invoked function execution, and then so we await the call of send message. And so what that does is it then calls send message. And then we get to the get user call, and perhaps that's another promise, or perhaps get user is actually an async function itself, and then we're able to await the result of that. And so again, while that operation is happening, we're able to process other requests in our application until the result is returned to us. And so once we get that value, we can assign it to user. We can then call the canSend method, passing in the user. We await the result of that. And then so much like the generator code we saw earlier, or even the promise code, if we return like a non-promise value from this, for example, when we return our false, this async function will end up resolving a false for us. And then finally, what we're able to do is call write message, which is our final async function. And once that completes, our code will complete as well. And so actually, we're now able to wrap our calls in try catches. And so previously, when we were working with those callbacks, we couldn't simply wrap them in a try catch. And then, of course, promises had their own pattern where we do it .reject. But in this case, we are able to try catch these calls. So within our async function, what we do is we're able to actually throw an error, and then it will be caught by that try catch. So the cool thing about async and await is that under the hood, they function as promises. Does anybody currently today have a code base that they maintain which is heavily promise-based? Cool, looks like a good number of you. Certainly at OpenTable, the code bases I work on are usually pretty heavily promise-based. And so another quick show of hands, anybody using a code base with heavy generator use? Very, very few. So for the most part, we as a community sort of jumped over generators. They came, they were presented to us, and we're like, that's neat. But for the most part, we didn't really pick up on it. Most people switched, jumped right to, or sort of kept using promises. The cool thing with this is that under the hood, it is promises. And what that means is it's actually very easy to refactor an existing code base. So in this case, we have perhaps 2 sets of code. So where we actually call the send message function, this could perhaps be within our controller within our application. So perhaps it's our express app.get handler. And so in this case, what we want to do is refactor from the bottom up. And so we're going to refactor our model code, which is down here. And so previously, in our fictional application, this model code was promise-based. And so what we've done here is we've rewritten it to use the async function, the async syntax, and then in our calling environment, we keep the code exactly the same. And then so this works completely as you would expect. The value which is eventually returned from our async function is what the promise resolves into. And again, if we, continuing with this refactor, if we throw an error within our async function within our model, we're able to catch it with our promise code with a .catch. And then, of course, we can do the exact opposite. So perhaps we want to refactor our controllers first, and then deeper within our model, we want to keep that promises for now. And so in this case, I have that async immediately invoked function execution. But of course, you could simply have your express callback handler be the async function. And then so that way you don't have to add a new function. You'd simply change your existing function by adding the async keyword. And then so we're able to await the call to our deeper promise model code. And then once we get the result, we're able to perhaps reply to the client request with it. And then in this case, we've kept the model code the same old promise style. And then finally, as you can probably expect, within our send message function, if we still return a rejected promise, it will end up being caught in our async function. So the two are completely interoperable. And finally, so of course the Node APIs, everything in the Node APIs are callback based. There is some work currently to start promisifying some of these built-in APIs. But if you want to start promisifying this code today, what you can do is you can use the util library, or you can use another convenient library, for example, pyfall. So in this case, what I want to do is, in this first line here, what I'm doing is promisifying a single method in the file system module. And so what this means is that the read file function, which is a callback style method in the file system module, will now become promisified, and that promisified version will be assigned to read file. Also, I'm going to use pyfall against the entire file system module, and then what that will do is we'll go through every single method in the module, and we'll create a sibling method with the word async appended to the name of the function. So now you can see below that what we do is we await the read file call. So that is now a promise, and we're also able to await this call on the file system module, and that is also a promise. Using a tool like pyfall with, for example, the Redis library is really great because I think if you use util.promisify, it might detach it from the Redis object. But at any rate, if you use util.promisify, you need to go through and you need to run it against many different methods. And so in like the Redis library, there's a method for each Redis function. And so this pyfall library is a real lifesaver. Unfortunately, I've also introduced a sort of bug in this code. Not really a bug, but this is something which can be the use of the use of awaited functions makes it really easy to start doing things sequentially when really you want to do it in parallel. So in this case, I'm awaiting a call to read file for the stuff.txt file. I'm also awaiting the result of the data.txt file. But those two are now being done sequentially when perhaps they should be done in parallel. And so if we wanted to do those in parallel, we could wrap those two calls in a promise.all, where we would then pass in an array, and then the two elements of the array would be these two awaited functions. Cool. Yeah, that's my story. Again, follow me on Twitter, or check out the book if you're into microservices. Thanks.